So you preferred your polar form. So you write, if fz is given, you uh, write u plus iv, fz is equal to u plus iv. So u and v may be rectangular form or polar form. Then you apply CR equation, find all the first order derivatives with respect to xy or r theta. So write CR equations and examine whether that equation is satisfied or not. So that is one part is over for analyticity. For second part, so just you see whether the that is first order partial derivative is continuous or not. So already I have told you, if there are four functions: exponential, that is your polynomial in z, or sine function or cos functions, or the function which is defined for all points. If it is a rational function, denominator should not be equal to 0. So that functions are always continuous. So just to write, this function is like that. It is a product of these functions. Since individual functions are continuous, so it is continuous. Otherwise, you see denominator is non-zero or not. If it is 0 for some value of z, then that function is not continuous at that point. So using analyticity of the functions, today I discuss about another function that is called harmonic functions. And then how will you construct analytic functions if real or imaginary part of the analytic function is given. Real and imaginary, either u or v is given. So from here you can get two questions, that is examine the harmonic functions, and second may be construction of analytic functions if real or imaginary part of the function fz is given. So it, see, so harmonic function means, so harmonic function is associated with your Laplace equation. You know Laplace equation. So Laplace equation on u is del square u by del x square plus del square u by del y square is equal to 0. That is second order partial derivatives. That is called Laplace equations in u. Similarly, that is the function is harmonic if suppose u is a harmonic functions, so it must be the solution of a Laplace equation. Laplace equation means del square u by del x square plus del square u by del x square y square is equal to 0, where u is a function of x and y. So that is harmonic functions. We say. Now you see harmonic function we defined, let fz is equal to u plus iv. Both are a function of x and y, and defined in the domain D. So u and v are said to be harmonic in the domain D if they have continuous second order partial derivatives. They have continuous second order partial derivative, because your Laplace equation is second order partial derivatives. That derivative should be continuous. The second order continuous second order partial derivative in D and satisfying the Laplace equation. So therefore, now it is a Laplace equation, Laplacian in u, del square u by del x square plus del square u by del y square is equal to 0, and for v like that. So here that is, since the function is partial second order partial derivative continuous, so for continuous functions, u of xy, derivative of u with respect to x and y is same as derivative of u with respect to y and x. First differentiate u with respect to x, then a y. So it will become del square u by del x del y. If you differentiate y first, then x, it will become just reverse. So for continuous functions, continuous partial derivative, so both values with respect to x and y or y and x, both are same. So therefore, you remember, because this is both are equal because of continuity of the second order partial derivative. So now what we learn here, the function fz is equal to u plus iv. So that is real and imaginary part. is said to be harmonic in the domain D if both have second order continuous second order partial derivative. That is, you will find second order partial derivative differentiate twice with respect to the variables, keeping other constant variables are constant. That is, all are continuous. Then again, that u and v satisfying the Laplace equation. Satisfy the Laplace equation means the Laplace equation, that is, u is the solution of the first equation and v is the solution of the second equation. That means u and v both are a solution of, if u and v are a solution of Laplace equations, then that is called also harmonic. U and v are solutions of the Laplace equations. So if the function f z u plus iv is analytic in a domain D, then real component u and v are always harmonic. That is because of properties. If the function is analytic, then automatically real and imaginary part is always harmonic. But if the function is u and v are harmonic, and if you construct the f z is equal to u plus iv, you cannot claim the function f z is analytic. Understand? Analyticity of the functions gives harmonicity of u and v. Both are u and v harmonic because the function is analytic. If u and v are harmonic, you cannot claim the function f z is analytic. Reverse need not be true. So here that is simply I have given you, if f z is analytic, implies CR equations and second order partial derivative is 0 automatically. If CR equation, if function is analytic, CR equation satisfied. If with the derivative, second order derivative, it will be 0. So, but converse need not be true. Harmonicity does not imply analyticity. So, what is harmonic conjugate? If two given functions u and v are harmonic, u and v both are harmonic in domain D. So ux, ui, vx, vy satisfy CR equations. Then v is called, that is the imaginary part of the function f z, is called a harmonic conjugate of u. V is said to be harmonic conjugate of u. It is not necessarily for u conjugate harmonic of v. It is not necessarily for u conjugate harmonic of v, but v is a conjugate harmonic of u because v is the imaginary part of the function f z. Right? V is conjugate harmonic. You remember that is conjugate harmonic conjugate or harmonic conjugate of v. U. V is said to be harmonic conjugate of u. So, but u cannot be conjugate harmonic of or harmonic conjugate of v. So now, if f z is equal to u plus iv is analytic in domain D, if and only if v is a harmonic conjugate of u. Another result, if f z is analytic in domain D, if and only if f z is analytic, then v is a harmonic conjugate of u. That is the, so I have given shortly proof. If v is a conjugate harmonic of in D, CR equation satisfied, CR equation and harmonicity will be satisfied, then u and v are continuous, so that is analytic. Let f z is analytic and u and v are harmonic, implies CR equation, implies v is conjugate harmonic. So just to remember this. So now question is, so that, now you start question, so that u is equal to y cube minus 3y square x is a harmonic in a domain D. Find the conjugate harmonic v in D. Conjugate harmonic v. That is the harmonic conjugate of u. Calculate, find conjugate harmonic of u, that is v. And corresponding analytic functions. All the parts are included here. You examine the function is harmonic. Second is, that is u is given. You calculate harmonic conjugate of u, that is v. If u and v both are known, then you can write f z is equal to u plus iv is the analytic functions. Now, if you are given corresponding analytic function, you write f z is equal to this. Now, what to do here? You see, u is given. Our aim to calculate v. So we are using CR equation, Cauchy-Riemann equations. So first examine for harmonic functions. So we find the second derivative of u and v with respect to x and y. So u of x is equal to, you see, minus 6xy. You see, partial derivative of u with respect to x, keeping y constants. So derivative of first term is 0. It will be minus 6xy. U of, what is u of xx? That means next derivative, second derivative of, that is the derivative of u of x with respect to x. It will become minus 6y. Similarly, u of y, u of y is equal to, first term gives 3y square minus 3x square, keeping x constant. U of yy is equal to also 6y. If you take the sum ux plus u of yy, it will become 0. So this implies u is harmonic in D because it is satisfying Laplace equation. So now I am going to construct the analytic functions. U is given, calculate v. Let v be the conjugate harmonic of u. So CR equation satisfied. That is, since function is analytic, CR equation is satisfied. U of x is equal to v of y. U of y is equal to minus v of x. When you construct the conjugate harmonic, so you have write your CR equations. That is constructionally made by using CR. U of x, this is a relation between u and v. So here u of x is known. Already you have solved this type of questions in a vector calculus. Calculate potential of the functions, scalar potential. So here u of x is equal to minus 6xy, already know. So u of y is equal to 3y square minus 3x square, already know. What is u of x? U of according to CR equation, u of x is equal to u of y, according to CR equations. Now we can write Vy is equal to minus 6xy. We can write by CR equations. V of y is equal to minus 6xy. So if you integrate with respect to y, keeping x constant, so we will get v, integration of v of y, keeping x constant. So it will gives, that is minus 3x, that is minus 6x y square by 2 to cancel, minus 3x y square by 2 to cancel, it will be minus 3x y square. Since we integrate with respect to y, keeping x constant, so it is a partial derivative, or that is it is a partial derivative of u is a function of x and y. So for ordinary functions, we have used for the integration, it is a arbitrary constants. But here, since it's a partial derivative, function of 2 variables or 3 variables, like that. So here, instead of arbitrary constant, we have to use plus arbitrary functions. We are at the time of integration, we keep x as a constant. Therefore, arbitrary function will be h of x. Integrate with respect to y, arbitrary function will be h of x. If you integrate with respect to x, arbitrary function will be g of y. Not you take arbitrary constants. So h of x is unknown for you. If you determine h of x and substitute here, that it will give the value of v. Next procedure, how to calculate h of x, right? Actually, this is v is equal to, what is the v? V is equal to minus 3xy square plus h of x, where h of x is unknown for you. Now, next step, our aim to find what is the value of h of x. So, therefore, v is already calculated, v is equal to minus 3xy square plus h of xy. So, now differentiate v with respect to x. Why you differentiate v with respect to x, not y? You see, this is arbitrary function is h of x. If arbitrary function is h of x, then you differentiate with the function with respect to x. Suppose arbitrary function will be g of y. So you differentiate that variable with respect to y. So it is not confused for you. So we have calculated v. V is equal to this is this plus arbitrary functions h of x. So since h of x we differentiate with respect to x. So differentiate v with respect to x. So it will be give, if you differentiate del v by del x is equal to minus 3y square. Right? Differentiate means at that time y treated as constants. So minus 3y square plus here h of x. So it is dh by dx, not partial derivative, because h is a function of single variable. So when you take the derivative with respect to x, so it will become dh by dx, right? So what is del v by del x? Del v by del x by CR equation, you see, it is nothing but minus uy by CR equations. So what is your u of, now u of y, now u of y, what is your u of y? You see, what is your u of y? Minus 3y square minus 3x square, right? Minus 3y square minus 3x square. Now we write that is u of y is equal to 3y square minus dh by dx, because this is our minus ui, so taking minus both sides. So come on, you will get u of y is equal to, so plus 3y square minus dh by dx. But u of y is equal to 3y square minus 3x square. So you put in left side and cancel the similar term. So comparing 3y square, it is wrong. Please rectify. It is not 3y, it is 3y square. Please correct it. Page number 4, first term 3y square minus 3x square is equal to right side 3y square minus h dash x. So 3y square will cancel. So we will get h dash x or dh by dx is equal to 3x. So if you integrate, because our aim to calculate h of, if you integrate, it will give h of x is equal to x cube. That is integration of a square is s cube by 3 cancel, s cube plus arbitrary constants, not arbitrary functions, because your function h is a single variable, function of single variable. So after integrations, it gives arbitrary constants. If it is a double variable, it will be arbitrary functions. Otherwise, it's single variable. So now already you know v is equal to minus 3xy square plus h of x. Already know, substituting the value of h of x, that is s cube plus c. So finally we will get v is equal to minus 3xy square plus s cube plus c is a harmonic conjugate of u. So next, you consider the analytic functions. If u and v are known, so now f z is equal to u plus iv, just substitute value of u, then value of v. So if you simplify, that is value of u and value of b, taking z is equal to x plus y. So for simplification, just put y is equal to 0 and x is equal to z. Replace, that is called Miller's-Thomas formula. So here, suppose you express f z in term of z. Here f z is equal to, since the function is f z, you have to write in term of z. So replace, that is in this expression, which has both involving with x and y, replace y is equal to 0 and x by z. If y is equal to 0, so imaginary part will be completely 0. So real part is completely 0. Imaginary part will be only I z cube plus c. The answer is I z cube plus I c, because I is a common to all this imaginary part. I z cube plus I c, that is I z cube plus a. What is your a? A is your complex constant. We write a. So what is your f dash z? F dash z is equal to 3i z square, just derivative, because it is analytic functions. So this is about the construction of analytic function in a rectangular system. So please, I requested all the students, you go through that example. If you understand this example, then if you know the shear equations, that is in a rectangular form, and you follow this procedure and you can solve the questions. Please go through this answer, answer of these questions. If you have any doubt, you may be discuss about that doubt. I will be clear. Please go through that. I will give just 2 to 3 minutes to check. So you have material with you. You check, please.
Hello, sir.
Hello, sir. Bolo.
Sir, means this means finding v, that is the conjugate harmonic function. It it can also be solved, means like there it comes out to be exact differential equation. So means sir,
Conjugate harmonic function.
sir, I am sending two images. Just please check that it is correct or wrong, sir.
Images.
Yes, sir, I am sending, sir.
No, now it is not possible because I am taking the class.
Sir, in the chat box, I am only sending.
Checkbox. So where is checkbox? I don't know. So I have told you already, you solve scalar potential, right? Scalar potential of the functions in vector calculus. That is same procedure here. But here you have to use your shear equations. If u is given, then by using shear equation you calculate v, right? So you see the procedure. I will check. Now it is not possible for me. So now Laplace equation in polar form. Already you know Laplace equation in a rectangular form, del square u by del x square plus del square u by del y square. Similarly for v, what is the Laplace equation of that rectangular Laplace equations? What is the rectangular form of the rectangular Laplace equation in polar form? So u is a function of r and theta. You know that is the real part of the functions f z. So then harmonic equation of u in polar system is your del square u by del x square. This is not it is a rectangular system. So it has a right harmonic equation u in polar system. That means I have written your rectangular system converted to polar form. So this is a rectangular system, and it is a polar form is del square u by del r square plus 1 by r del y del r plus 1 by r square del square u by del theta square is equal to 0. So there is a derivations for this case in vector calculus, how that is your rectangular to polar. Here you just remember That is this equation, if you use a function of r and theta, so the Laplace equation, here Laplace equation in rectangular two terms. Here in polar form, it is three terms. Del square u by del r square. It is easy to remember. You see it. Second derivative of r with respect to u. Then 1 by r, first derivative of r, plus 1 by r square. The exponent of denominator of r is increased. 1 by r square del square u by del theta square is equal to 0. In short form, you write u of r plus 1 by r ur plus 1 by r square u theta theta. Similarly, Laplace equations in of v in polar form. Similarly, v of r plus 1 by r vr plus v theta theta by r square is equal to 0. So remember this two form. That is, if a question in polar form, you remember your shear equations in polar form and a Laplace equation in polar form. So find the conjugate harmonic of u is equal to ln r mod z, ln mod z, and the corresponding harmonic functions v, also analytic functions f z. You see u is equal to ln mod z. What is your z? If z is equal to r e to the right theta, ln z is equal to u is equal to ln r, ln r, because mod z is equal to r, you know. So u is equal to ln r. So then this is the real part of the function f z, real analytic functions. So now what is the shear equation I have written here? R ur is equal to v theta, r vr minus u theta. So now u is given, you find the derivative with respect to r, del y del y is equal to 1 by r. So now by shear equations we will get r, if you multiply r this, r there is a er equation, shear equation, r ur, what is that? R ur is equal to 1 here, that is equal to v theta, right? So from shear equations, already I have given shear equation here, the first two lines. R ur is equal to v theta. So you will get ur is equal to 1 by r. Multiply, so r ur is equal to r. That means v theta is equal to 1. If v theta is equal to 1, then differentiate according to this, differentiate v theta with respect to theta. So it will becomes theta, because it is a constant theta plus difference with theta, then it will be h of r. H of r, that is the arbitrary functions of r. Then if since it is h of r, so what will do? Differentiate v with respect to r. So it will be vr del dv, that is v del v by del r is equal to, since it difference with respect to r, so theta is equal to 0, only dh by dr. So what is that quantity? Vr is equal to, you know, Vr is equal to, what is Vr? Vr is equal to minus u theta by r. Vr is equal to minus v theta by r. So that is equal to minus u theta by r by shear equations. Now summarize it. So minus u theta by r is equal to h dash r. So u theta is equal to minus r h dash r. But what is your u theta? Already you know u theta is equal to 0, because theta part is 0. U theta, because u is a function of only r, there is no theta. So derivative of u with respect to theta is equal to 0. Therefore, you see h dash r is equal to 0. So if you integrate with respect to r, so it will give a constant. So what will be v? V is equal to, you see, what is your v here? V is equal to v theta plus hr. Hr is unknown. So next step gives the value of hr. Since hr is equal to constant, so we write v is equal to theta plus c. So fz is equal to u plus iv, that is ln r plus I theta plus c. That is in polar form. This question is meant for polar form. But these questions, if you don't know the polar equations and with this, so you can also check. This is harmony functions. U is harmony functions. If you check harmony function, what will do here? So you calculate del y del r already. Del y del r is equal to 1 by r. What is the del square u by del r square? That is minus 1 by r square. Minus 1 by r square. You see, if you substitute minus 1 by r square plus 1 by r into 1 by r, that is 1 by r square, and u of theta is equal to 0. So this first two term will cancel in because both are opposite sign. So result is 0. So satisfying Laplace equation. But if you solve these questions, suppose you solve this question by rectangular form. What will be rectangular form u? So mod z is equal to square root of x square plus y square. So u become half of ln x square plus y square. If you find the derivative, suppose you want to check your Laplace equations, you find del y del x, del square u by del x square. It is very difficult and very lengthy. Finally, you will not get any answer. Similarly, if you consider the analytic function taking that half ln x square plus y square, so you will not reach to your goal. That is 2 or 3 pages you will be, that is a time lost, paper lost. So finally your answer may be incorrect. And if you will get correct after 3 or 4 pages. But if you apply the polar form for this case, so it will become very easy and within a few lines you will get the result. So here, so it is analytic functions. So is also harmonic functions. I have solved these questions. Del y del r plus u r by this is equal to 0. So here u of r is equal to this, u of r is equal to minus r square. If you substitute u of theta is equal to 0, substitute it will be 0. What is its derivative? Derivative of the function. F at z is equal to, you know this formula. You remember this formula, e to the minus I theta ur plus I vr. So just you substitute ur and vr, you get the result. That is the derivative of the function is 1 by z. That is because what is your fz here? You see fz. If you take fz is equal to this ln r plus I theta. Ln r plus I theta. What is that things? Ln r plus I theta. Can you write in z form? Hello. So now next question. Let fz is equal to 1 by z. Z is not equal to 0. Examine shear equation, harmonic, and find f at z. This question for you. So that's z is not equal to 0. Therefore, it is analytic everywhere because z is not equal. Examine shear equation. For shear equation for this question, so 1 by z. If you write it in term of x plus y, z is equal to x plus y and its conjugate. So you can write, but it will be little difficult for you find the derivative. Rather, this question you take in polar form. In polar form, this question will be easy for you. Similarly, question 2, u is equal to minus cos hyperbolic s and cos y. That is defined in D. Then show that u is a harmonic function. Also find a harmonic conjugate of u and v. Find fz. So you should know what is the derivative. When it is the derivative with respect to x and y, what is the derivative of cos hyperbolic functions? Derivative of hyperbolic function. You know, derivative of cos x is minus sin x, and derivative of sin x is cos x. So for hyperbolic functions, that is sin x is equal to e to the x minus e to the minus x by 2 harmonic functions. Cos hyperbolic function x is equal to e to the x plus e to the minus x by 2. So there is no side. If you take the derivative of sine hyperbolic function, it will be cos hyperbolic function, and derivative of cos hyperbolic function, it will give sine hyperbolic function. There is no negative sign. You see the difference. Derivative of cos x is minus sine x, but derivative of cos hyperbolic x it becomes cos sine hyperbolic x. So here apply the same procedure to prove this function is harmonic. Then find it conjugate harmonic function, conjugate harmonic functions, and FHR. So show that U is equal to this as a harmonic, and find its conjugate harmonic V. This is also a questions. U is equal to x by x square plus y square. If you find, imagine, if you take the first derivative and second derivative of U, so it is very difficult for you, right? Directly, if you not think of about the how you solve these questions, when the question is looks very easy. Del by del x you find easily. When you will find del square u by del x square, you will find, but that is many cancellation and big expression. Here what will do? I have given the hints. Put x is equal to r cos theta, y is equal to r sin theta, polar form. Convert into polar form. So z is equal to r e to the right theta. So it will become what is that? U is equal to what is that? X is equal to substitute r cos theta. So x square plus y square become r square. So it will be cos theta by r. U is equal to cos theta by r. If u is equal to cos theta by r, you can easily apply your formula for CR equation in polar form, and you can examine the harmonicity of the functions. So just you think of the question and solve like that. So this is about harmonic functions. So today, for this class, if you have a doubt, you can ask me. Where you have, if you have a doubt, you can discuss with me freely. So that students told me he has solved in differential. So actually, I don't know, or I have not seen that part, right? If you solve that questions, that procedure may not be applicable for all. Acha, BT 819 BT 818 biotechnology 818. Hello.
Sir, I think only physics and electrical students are here.
ये मैथमेटिक्स है ये ना नहीं what is that? Sorry. So this is attendance for first semester. All right. Siddharth Shekhar 217. Siddharth Shekhar.
Yes, sir.
So for today class, you have any doubt?
No, sir.
No, sir.
When I read the document, then I'll make some doubts.
Right. 237 Suta. 217.
Present, sir. 237 present.
Present. You have any doubt?
No, sir, not as of now.
At least you solve the questions what I have given, and what book you have available with you, Krejcik or Churchill?
Krejcik, sir. Krejcik.
Huh?
Krejcik, sir.
ठीक है. So you solve the question from KG. How will you construct the analytic function? Many questions are given in the exercise, and you go through the example, right? So
Okay.
as a 245 to electrical 245. What is the name? Moragoda.
Yes, sir.
You are present?
Yes, sir.
Hello.
Hello, sir.
You are present 245.
Yes, sir. 245.
Why you are absent yesterday?
Yes, sir. I was absent yesterday. I wasn't in home.
So
yesterday.
any doubt for this class?
No, sir. I go through the notes and video yesterday, and it's fine.
You are? Then 256. Komalika Patra.
Yes.
You have any doubt?
No, sir. No, sir.
If you have doubt, you ask me.
No, sir. I have solved the questions. As of now, I have no doubt.
Very good, very good. As a 611. Mohammed Mohsin. 611 electrical.
Yes, sir.
You are?
Yes, sir.
Any doubt?
No, sir.
Not. So next class I will check your answer book because there is a 3 days holiday for you. So when you come, I advise to all the students you come with your notebook where you have solved the questions. So when
Okay.
I'll call your roll number, just you on your video and you show me page wise, right?
Okay, sir.
615 Jaspal, 615
Yes, sir.
Jaspal,
Yes, sir. Yes, sir.
Jaspal. So any doubt?
No, sir. Right now, I have no doubt.
ठीक है. So Abhishek Biswas 619 Abhishek Biswas absent. I will give the cross here. अच्छा आशीर्वाद
Yes, sir.
Das
Present.
620.
Yes, sir. Present.
So you are yesterday absent.
Yes, sir.
Karan Das 622 Karan Das present or absent? 622 Karan. Six 29 Satyaprakash 629 Satyaprakash.
Present, sir.
You have any doubt today?
No, sir.
So 647 Piyush
Yes, sir.
present, no doubt.
Yes.
648 648
Yes.
648.
Yes, sir.
So absent tomorrow, yesterday.
Yes, sir.
Manish Kumar 880.
Present, sir.
Good. Any doubt? Acha 883 Samasant Mahalik 883. 887 Goppu Vishal
Yes, sir.
Reddy.
Yes, sir.
You remain absent yesterday.
No, sir.
Electrical 980.
Yes, sir.
Sisir Kumar. Any doubt, Sisir?
No, sir.
Very good. Physics 5034. Ravinder. 5034, Ravinder. There Jyotirmaya, physics. Jyotirmaya Varman. 5025. Silas Ranjan, physics 5026. Silas 5026, physics 418. 418. Sorin Naskar 5028.
Yes, sir. Yes, sir.
Any
Sir,
doubt?
I have a question aside from your class related to complex analysis. Can I ask?
So I have advised to Ansuman and also other students. Please, Ansuman, is a WhatsApp group. You have a WhatsApp group for mathematics. So if you have a doubt for any students, so you give your doubt, you send your doubt through WhatsApp group. So I advise other students, those any students can solve that questions. Please give the answer of that questions, clear the doubt for that your friend. So just I will be check how you send the doubt and that the students, the particular students who has solved that questions. That is one type of I will judge here. How many doubts and the students who that is student who has solved that questions, that will be credit to that students, those are solved the questions and you solve in a paper and so send to the in WhatsApp group for all. Ansuman? Ansuman?
Yes, sir. Yes, sir. I'm listening.
Are you are understand my point or not? It is a online class. So doubt for individual doubt is not possible. It is not general class. So any student has a doubt, he has to send that doubt in WhatsApp group. I am a member. I can see that doubt and how many ways the students are solved and send that in that group. I will also observe, right? So it will be good for all the students. Those have a doubt and those are clear the doubt. It is a good for them, right?
Yes, sir.
So for theory part, if you have any doubt, you can ask me after the class. Otherwise, all right, I will take the actors at first. Silas are present. Then sorry, Sorin present. So 5031, 5031,
Yes, sir.
5032, 5032. Bhaskar Sai, Ayush Sahu, 5033, 5034.
Yes, sir.
Good. So you have any doubt? Right. 5035.
Present, sir.
5062.
Yes, sir.
5062.
Yes, sir.
What is your name?
Neeraj.
Good. 5066.
Yes, sir.
5071.
Yes, sir.
5076. 5076. Physics. So rest are present today. Of course, officially I download your attendance. 5 minutes I will give the chance. Then I download your attendance. It is officially recorded. Those are present in that class. So if you come lately, so your roll number come to the picture download system. So I will match both download and this attendance today. Then I will send fill up your attendance sheet in online. Nitrish. So like today class is finished. You go join next class. I'll go to next persons. new portions. Either it is conformal mapping or integrations. Right?
Merry Christmas in advance.
The student who has a doubt, say one student told me, sir, he has a doubt. What is that doubt? Please
Yes,
tell me.
yes, sir. I have sent in the chat box. Please check.
Sir, it is a question actually, not a doubt specifically. The question is that in the space-time curvature, we can consider time as a complex number. Okay, so our calculation will be easy. Then can we use complex analysis in this case, in the space-time calculations?
So, it is general or it is only for complex analysis?
No. My question is actually in general relativity, there is space-time and the time is complex number. So the calculation become easy. Can we use complex analysis in the calculation of the time things there?
So please send the answer through WhatsApp group. I will check. Right?
Okay, sir.
You give the answer and take the photocopy and send in WhatsApp group. So, I advise to Ansuman and other fellows. So you have to actually you have availed that facility. You send your group doubt through WhatsApp group, and some of your there are many students are brilliant in your class. So those are solve the question and send that answer for that. So everybody will benefit for that, because everybody can check that answer. Those are solved, it is all right. Those are not solved, it will help for them. Right? So
hello,
now happy Christmas for you. Enjoy 3 days holiday. But I have given the assignment. So till now you solve the questions from Magic and the theory part also. I have some theory I have given to you as a problem. So you solve and prepare a good notebook. That notebook with you, and when you come to the campus, that notebook come to me as an assignment. So next class Monday, I will be first. I will be arbitrarily call the students. So those students' name I will call. Please switch on your video and show page wise what he has solved. Right? I'll let you leave and go to other classes. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
hello, sir.
Hello.
Hello, yes, sir. Sir, actually, can you check about my sir? Actually, I'm Siddharth, sir. I've registered late for the course. So, can you check my attendance, sir, once? It's 116
Siddharth.
Yes, sir.
Siddharth, your serial number you know?
Yes, sir. No, sir. Serial number I don't know. So, my roll number is
You're
116.
electrical or physics?
Electrical, sir. Electrical.
Electrical. Please, just I'll be see from very beginning. Siddharth. Siddharth Shekhar.
Siddharth Raut. Siddharth Raut.
Raut.
116, sir. 116 EE0337.
116.
Yes, sir. 116 EE0337.
Double E 116.
Yes, sir. 116.
Double E
116
119 electrical. Then
no, sir. 116. 116.
116.
Yes, sir.
So 116, there is no 116. Perhaps I have not take the printout of that.
Sir, actually, I registered late for the course, sir. So my name got added.
If I will take the printout, it is an old printout. Perhaps in a new printout, I will take the printout and I will inform you next class. Right?
Yes, sir. Please, sir. Thank you, sir. Please do add my name, sir. Yeah. Thank you. Okay. Thank you.
Sir, can you check my name also? I have registered late for this course.
I said, hey, Ari, this I have taken your first or second class, this printout. So it is 127 students. If you are late registration, your name come in new form. So I will take the name new printout for attendance. So perhaps in new printout you have a name, right? I will check. I will check and I will. So I have when I download your attendance. So automatically your name come in the system if you are registered, right? So this is my physical and another is official download, right? ठीक है
Yes, sir.
Sir,
हाँ,
sir, sir, I joined late by 10 minutes, so my name must not be there in the attendance, but I'm present.
So I call that, I called you or not?
No, no, sir.
So already, since I download the system, I cannot do anything. Already it is downloaded. So how will you change it?
Sir,
So at least I have taken I take the download after 5 to 7 minutes. So your class start from 3:15, but I downloaded at 3:22. I have given 5 to 7 minutes to the students. So come and join. Right?
okay.
All right. Thank you.
Thank you, sir.
Thank you. Thank you. Thank you to all.